it's a problem like this, yes.
I got 5.
You got 5? Yeah? Plus or minus 5? Yeah, okay, so let's work this out piece by piece. This is a simple expression here, simplifier. So we have plus or minus. What's that? Write the formula? Well, this isn't necessarily a formula or anything. It's just an expression. What's that?
Are you solving it?
I'm just simplifying it. Just simplify it.
So you just said square.
Yeah, so 6 squared we have is 36.
Why that square root of 88?
What's that?
Square root of 88.
Square root of 88?
Plus or minus.
Okay, let's see what happens. So we have 36 minus this whole product. Okay? So it can be very easy to make a simple mistake, so let's try our best not to make an easy simple mistake. So if you minus this whole product, well, this product here, is it going to be positive or negative? We just look at 4 times negative 1 times negative 11 fourths. Is that going to be positive or negative? It's going to be positive because you have a negative times a negative. Okay, so there's 2 ways to do this. Okay. There's 2 ways to do this. You can go minus and then look at this, or you can change this to addition and go plus negative and figure out that whole product. Whatever you do, just make sure you're careful. So if I say minus, okay, now I'm just looking at 4 times negative 1 times negative 11 fourths, which is positive, because 2 negatives make positive. So now I can just ignore the sign and say, okay, what's 4 times 1? 4. And then 4 times 11 fourths. 4 times 11 fourths, if you guys do it off to the side, which is 44 over 4, but you can also simplify before you go across, and you'll just see that it's 11. So you have 36 minus 11. If you got something different than this, then you may have made a simple mistake, and maybe you did 36 minus negative 11, but be careful, there's only one correct value here. And then you have plus or minus the square root of 36 minus 11, which is 25. So good job for those of you that got plus or minus 5. Notice for 25 is 5. So this is really a lesson on just being very careful with your arithmetic, being very careful. Okay, is it positive? Is it negative? Which one is it? Because if you get it wrong, then the whole thing's wrong. Okay. So today we're going to try to answer the question, what is the discriminant and what does it tell us? Okay, before we do that, I asked if there's any questions on the homework. The last class they wanted to look at number 40. So let's look at 40. I know it might be hard to see in the back, but 40 starts off as, and again, this is the homework. This is on page 125, or sorry, page 100. Okay, so page 100. Some of you may have struggled with this, but let's take a look at it. So we have t squared over 20 plus 8 equals 15. There are 2 primary ways to solve this. One way you might decide, okay, well, I can just get everything on one side and then just solve for t squared, solve for t that way. So I'm going to show you both, and you guys can decide what's best for you. Now the way on the right-hand side is going to work no matter what. No matter what it is, as long as it's quadratic. Now in this particular case, notice there's no t term. It's just t squared over 20 plus 8 equals 15. So if we go ahead and we were to multiply, first subtract 8, right? Get rid of the 8. So now you're here, t squared over 20 is equal to 7. And now you don't really care what t squared over 20 is. You want to know what t squared is, so you multiply both sides by 20. So now you have t squared equals 140. And you want to solve for t, so if you square root both sides, this is where you have to be very careful, and this is why I don't recommend doing it this way if you think you're going to forget to do this. If you feel like, oh, I know I'm going to forget to write plus or minus. Because there are two solutions to this. There can be up to two solutions. In this case, there are. And so when you square root both sides, make sure to put plus or minus in front. So t equals plus or minus the square root of 140. And that would be your answer, but we should be able to go ahead and simplify it. And a way to simplify radicals using the prime factorization. This method works every time. Right, the radicand of 140. Again, the repeating question, what prime number, what's the smallest prime number that's a factor of 140? 2. 2 is the smallest prime number, and it's a factor of 140, so you have 2 and 70. And just keep repeating the same question. What's the smallest prime number that's a factor of 70? 2. And then you have 2 and 35 makes 70, and then smallest prime number that's a factor of 35. 2 no longer works. You go up to 3. 3 doesn't work. Go up to the next prime number, which is 5. Oh, 5 works, 5 and 7. So notice any whole number 2 or greater is always going to break down to its prime components. 2 times 2 times 5 times 7 is 140. Because it's the square root, circle pairs of a number. If it were the cube root, circle sets, groups of 3. But it's just a square root, so I circle a pair of 2's, and that's the only thing that makes a pair. So I'm left with 5 and 7 left over. That's going to be what's left underneath the radical. So circle the pair of 2's, so a 2 comes out to the front, because you can think of it like, okay, well the square root of 4, that's why it works the way it does. Okay, 2 in the front, and then what's left over, 35. So the most simplified way to write the solutions for this equation, plus or minus 2 root 35, or square root 35. Please ask any questions. Are there any concerns about how I do this on this side here? Okay. If you feel like this is like something new or something that you have to memorize, I would say don't necessarily have to worry about doing it this way. We can always do it the way we've been doing it, and that's what I show here on the right-hand side. So if we go here and look at the right-hand side, let's go ahead and go with what we know. We know the quadratic equation, we know how to deal with it, so let's get set equal to 0 like we're used to. So on this method over here on the right, set it equal to 0 by subtracting 15 from each side, and now you're here, and then you see, okay, well, what I did next was I multiplied the whole thing by 20 just to get rid of fractions. Remember, you can do that at any point. If you don't like fractions and you want to get rid of fractions, go ahead and multiply both sides by some constant to get rid of fractions. So that's what I do. I multiply this whole thing by 20. Now make sure it's each part too. It's the entire left-hand side, it's the entire right-hand side. 20 times t squared over 20 is t squared. 20 times negative 7 is negative 140. And this equals 0 times 20, which is just 0. So this you might like to work with more than when you have fractions involved. Now, if you want to keep it the way you've been doing, like, okay, I know tic-tac-toe or I know long AC method, I'm going to make up a t term, a 0 t term, just to fit it, because I know that I need that. I need my b for when I do tic-tac-toe, I need my b for when I do long AC. So just make it up. You can make up any term you want. 0z, for example, is nothing. In this instance, we want 0t, so that we have, you know, the form we're used to, at squared plus bt plus c equals 0. Now from here, what you're going to find out, if you go ahead and if you attempted tic-tac-toe right now, you say, okay, AC, so A is 1, C is negative 140, so AC is negative 140. E is 0. Okay, so if you try tic-tac-toe, it's either going to work or it's not going to work. Factors of negative 140 that add to 0. Okay, well, they're probably going to be fairly close in terms of their absolute value. So you say, okay, well, let me try, I don't know, negative 140, it's 140 and 10. It's 10 and 14. But they don't add, with 1 being negative, they don't add to 0. So I say, okay, well, maybe a little bit larger than 14, maybe 15. It's probably not going to work, though. In fact, it doesn't. It comes out to a non-integer value. So you say, okay, maybe one more time, I'll try 140 and 16. And you get 16, you get a fraction, and you're getting further and further away in terms of the absolute value. So with enough quick testing, you're going to find out nothing works here. So it doesn't work. And what do we do when we can't factor? We jump right to the quadratic the quadratic formula, which you guys have in your textbook, and I will be making copies probably at the end of the day, give to you tomorrow. The end of course, so thankfully they do give you this for your EOC. They do give you the end of course reference sheet, and the very first formula is the quadratic formula. Some of you may have memorized, which is good, especially moving forward in your future math courses. But negative b plus or minus square root b squared minus 4ac all over 2a. That sounds familiar, should sound familiar. But you're provided it now, so you'll be fine for this course. But it's not a bad formula to memorize. All right, so let's go. So using that formula, where I would say t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's this guy being used right here. You guys have used this before, correct, in your maybe previous math class? Some of you know? So some of you this may be new. Okay, for those of you that are new, understand this. The quadratic formula, as strange as it may look, and it is kind of a mouthful to say, kind of a mouthful to memorize, but as strange as it may look, it can solve any quadratic. So it can solve any quadratic. Now, typically you see it as x equals. I'm using t equals because that happens to be the variable that we're talking about. But regardless, this part is always the same. Negative b plus or minus, all over 2a. Yes?
What's the plus minus?
Plus or minus. It says, okay, one solution to t is when you have plus. Another solution is when you have minus. It's a condensed way of writing both. Good question. Like the very beginning of the lesson today, we had to warm up, ended up being plus or minus 5. So you could say this is 5, or this is negative 5. It's just a condensed way of writing it. Yeah. So if we do this, let's fill it out so we're all on the same page here. So we have the quadratic, which is when at squared plus bt plus c equals 0. We can apply this. It's there. It's where we're ready to go. So t equals negative b. Well, b is 0. Negative 0 plus or minus the square root. Well, b squared. Okay, so 0 squared minus 4. Now ac. A is 1. And c is negative 140. So 1, negative 140. All over 2a. All over 2 times 1. So a, b, and c, once you have them set, they don't change. It's just a matter of just plugging in. You'll be given it. Yes. No, you're good. What is it?
I don't realize, I can't see where you got the 0t from.
Okay, I made it up because I wanted to have it fit the form at squared plus bt plus c. So notice we don't have, in here we don't have a t term. We have a t squared and we have a constant, the c. So for me to use this perfectly, I'm just showing, okay, you could literally write plus 0t, so you can see that, okay, b is technically 0. Right? Because what is 0t, David? It's nothing. So do you agree that t squared plus 0 minus 140 is the same thing as this?
Yeah.
Yeah. So it doesn't affect the value of it. It doesn't affect the value. So okay, it doesn't affect the value, so I can do that. So I can clearly see a is 1, right, in front of the t squared, so it's going to be 1. B is 0, and c is negative 4. You don't have to do this. If you look at this and you can see, okay, I know my b is 0 because I don't have a t, then you can jump right here. But just to be safe and be very clear, I'm going ahead and I'm writing 0t in the middle. So you fill it in, and then now it's a matter of simplifying. Now this, again, be very careful at this point. You'd hate to get to this point and then make a simple mistake from here to here. So you go ahead and you go, okay, now simplifying this. So it's like 0 squared minus 4 times 1 times negative 140. Okay, so is this whole thing going to be, I know you can see, but is this whole thing going to be positive or negative? 0 minus 4 times 1 times negative 140. And the way you'll know is you'll have what? You can change this to plus negative 4 times 1 times negative 140. And what's negative times a positive times a negative? Positive. There's an even number of negatives, so it's positive. If you're not sure, just use your calculator to be extra careful. You punch in your calculator -4 times 1 times -140, it is going to be a positive number. It would be positive 280. Now for this particular one, I've left it as a product of 4 and 140. You can go right to 280 and then prime factorize and it'll all work out the same, yes.
It's 560.
560. Oh, I'm sorry. 4 times 140, thank you. 560. So this is actually 560. You can do 560 and then prime factorize that, and you'll arrive at the same thing. But because I know when I have a product in my radican, I can bring a guy out if it's a perfect square. I know the square root of 4 is 2, so I just bring it out, and now I just deal with 140. And we've already done that work here. We know that the square root of 140 simplifies to 2 root 35. Notice here the 2 and the 2, I simplify to 1, 1. So if you want to see that. Oh, wrong thing. 1 and 1. Right? 2 over 2 is 1 over 1. So then you just have plus or minus root 40. So plus or minus 2 root 35. Any questions about this problem? So here was the quadratic formula. Yes?
With is that -0? T equals a -0?
Yep, -0, negative b. Yep, negative b. -0 is kind of a silly thing to say. -0 is just 0. 0 has no real charge. No, it's not positive or negative. I don't know why I use the word charge. It's more like chemistry talk with neutrons. But yeah, it has no positive or negative. It's just neutral. All right, no questions about this? Okay, so another one that a student wanted to see that may help you guys is number 39, for those of you that didn't get it. So 39 starts with u squared equals -9u. Now, I could set this equal to 0 and do the same thing that I've been doing. Say, okay, make it fit the form. au squared plus bu plus c equals 0. In which case, if we want to do that, we can say, okay, plus 0 equals 0. We can fit in that 0 for c. But for this particular problem, I notice they have a common factor, these two terms, the u squared and the 9u. They have a u in common. So I factor out the GCF. I will always factor out the greatest common factor first, because it's a factor and it makes it more simple. And for this one, I'm now pretty much done. Once I factor out that u, I just now have two linear factors, which are easy to solve for individually. This could be 0, or that could be 0. Solve for each one individually. Obviously, this one already done, u equals 0. And the other one here, u plus 9 equals 0, subtract 9 from each side, u equals -9. I found the two solutions. I found the two solutions, or you might call them zeros or roots. Yes?
What if you subtract u squared? What if you subtract the
What if I start off, I subtracted u squared?
Yeah.
Okay, so it's a good question. So let's see this worked out. And I actually saw some of you approach a problem like this on, I believe, either the homework or the quiz, where you did that. That's fine. Watch what happens. So if you have, so I'll do an or. I'll show you another way you can do it. So let's say for some reason, it doesn't matter, you went ahead, you start off with the same problem, u squared is equal to -9u. If you wanted to subtract u squared from each side, you say, okay, 0 is equal to -u squared minus 9u. There's nothing wrong with this. And it doesn't matter whether you factor out a u or whether you factor out a -u. You will come up with the same solution. Let's go ahead and see that. Right? You guys want to see me, which one do you want to factor out, a u or a -u? It really doesn't matter. Okay, so I'm just going to factor out a u. If I factor out a u, I would be left with -u minus 9. Right, you can always make sure, okay, -u squared minus 9u, okay, I'm good. Now we're at the point where it's like, okay, u could equal 0. Hey, that's the same thing I got there. And this could equal 0. Or this could equal 0. So then add 9. So -u is equal to 9, divide or multiply this by -1, so u is equal to -9. Notice it doesn't matter how you do it, so good question. Alright, again, so for today, what is the discriminant and what does it tell us? If you noticed on here, I actually first point out the discriminant. The discriminant is when you're using the quadratic formula. The discriminant is the radicand part. The value underneath the radical. That is the discriminant. Yes?
And you're done thinking number 43.
Number 43? Sure. So let's look at 43. So for 43 from the homework, you had 7 times x minus 4 squared minus 18 equals 10. 43, page 100. Okay, so you may recognize that this is, of course, a quadratic, and that's the problem you're dealing with. You know, if I went ahead and expanded this, I would have a squared term would be my highest degree term, so it's definitely a quadratic. But is there any way to solve this easily? Yeah, so we'll start with get equal to 0, bless you. So if you go ahead and you subtract 10 from each side, so you have 7 times x minus 4 squared minus 28 is equal to 0. Bless you. I do see something that actually is kind of intuitive, but I'm not going to do it just because it's...
You have to, actually distribute the surface into,
Well, not first. Yes? Yes or no? So not first, you say distribute the 7. Are we allowed to distribute the 7 before we square? No, no. Order of operations says otherwise, right? Order of operations says, right, PEMDAS or PIMA, with multiplication, division, the same thing, addition, subtraction, the same thing. So it says we have to do exponents before we do multiplication. It comes before multiplication, so you have to take care of this first. So what is this? Well, I always say go ahead and do it the long way. That way you avoid making some sort of mistake. Actually, go ahead and show x minus 4 times x minus 4. So now the way I wrote it now, it doesn't actually matter if I distribute the 7 first or do these two, does it? Because now it's all multiplication. And for multiplication, order doesn't matter. So if you want to distribute the 7 first, so let's say this one, it doesn't matter which, and then whatever that is, then do your foiling, go ahead and do that. I'm going to go ahead and FOIL first. If I FOILed, what would I have? Mary, help me out here.
x squared
Uh-huh.
minus 8, right?
X squared minus
8x?
8x?
Yeah.
Okay.
Plus 16.
Plus 16. You guys, you see what she skipped? She did x squared minus 4x minus 4x, which is negative 8x, and then negative 4 to negative 4 is positive 16. You combine two steps into one, where you did the outside and the inside. And if we continue, minus 28 is equal to 0. Yep, we go distribute, so we're going to do that now. So 7 times x squared is 7x squared. 7 times 8 is 56. 7 times 16, thank you, 112 minus 28 is equal to 0. Now we're going to combine like terms, because we want to get to the, no matter what we end up doing, we want to get to the point ax squared plus bx plus c equals 0. That's simple. So if we go ahead and combine like terms, 7x squared minus 56x, 112 and negative 128.
84.
Is it 84?
Yeah.
Okay. Thank you. Now you're going to notice that we could factor out a 7 now. And the reason is because this guy was a multiple of 7. But you may have not noticed that. But I'm definitely going to do it. It'll make it more simple. So if I go ahead and I circle, it's off the chart there. So let's just do it this way. Everything will move together. We got lucky. All right, so I'm going to factor out that 7. I'm going to get x squared minus 8x plus 12 equals 0. All right, so now, can I do short AC? Am I allowed to do short AC?
Yes.
Yes, and why can't I? Because the A coefficient is a 1. So x, and factors of 12 that add to negative 8. Negative 6 and negative 2. And you can even check x squared minus 2x minus 6x plus 12, it works out. So if we look at this, we have so now we're here, so we can say x minus 6 could equal 0, or x minus 2 could equal 0. Adding 6 to each side, x could equal 6. Adding 2 to each side, x could equal 2. And those would be your two solutions. Yes.
How did you take out 7 from it?
From where? Which point?
The 7 times x2.
Here? I noticed that all of these had a common factor of 7. So you can always factor out the greatest common factor. Oh, thank you. Okay. Thank you. All right, so x equals 6, x equals 2. And you know, question about the 7? That's the greatest common factor of all of these. Right? 7 is a common factor of this, this, and this, so I factor it out. It makes it easier to deal with.
But you keep the 7 when you reach the
Keep this, yeah, because I factored it out, so I'm gonna keep it. It's a good rule of thumb to go ahead and keep it for now, because especially if you start factoring out something that contains a variable, you don't want to think about dividing both sides by 7 and the 7 goes away. It's safer when you're in the factoring mode, leave it as a factor. So I'm going to leave it there. And then I went ahead and factored this trinomial using short AC. X equals 6, x equals 2. And I could also check these if I want to check them, if I have time. If I plug in 6, it should make it true. If I plug in 2, it should make it true. All right, any other questions about this problem? Okay, so moving on. So let's understand that the quadratic formula, which is this, x equals negative b plus or minus square b squared minus 4c over 2a. I'm going to rush through it because it's the same thing over and over. So this solves any quadratic. So if you're having trouble factoring, if you're having trouble figuring it out by factoring for some reason, first off, if it doesn't factor, you have to use the quadratic formula. You have no other option. But let's say even if you maybe somehow knew it factored, but you're making mistakes, just use a quadratic formula. This solves any quadratic, even if the roots are imaginary roots. So, the discriminant, which is the focus of today, is this. The discriminant is just this part here, just the radicand, b squared minus 4ac. And the discriminant tells us the nature of the roots, and I'll show you what I'm talking about on the next slide. So if you do this, if you just do b squared minus 4ac, its value, whether it's positive, negative, or 0, will tell you information about your quadratic, its graph, before you even graph it. Anyone need more time on this slide? Notice it does not include the square root part. It's just the radicand, which is the value underneath the square root. Good? Okay, so here's the scenarios here. If the discriminant is positive, negative, or 0. If it is positive, if b squared minus 4ac is positive, you will have two real roots. Remember, this is the symbol for real numbers. If it is positive, you have two real roots. If it is negative, you will have two imaginary roots. And if it is 0, you will have one real root, and we call that to say it has a multiplicity of 2. I think actually we had an example that we just did, or we just did this earlier today, where we had this scenario right here. We had factored it, and it was the same thing twice. Or we didn't. That's the scenario that you have when you're solving it analytically, and you get to a point where it's like, for example, x minus 4 times x minus 4 equals 0. X equals 4, that's the only solution. That's the situation where we say x equals 4, and that one has a multiplicity of 2. And you can see it in factored form when you had x minus 4 times x minus 4. It like repeated almost, at least analytically it did. So, here are the three scenarios. We're going to look at graphs of parabolas on the next slide. And we're going to see which is which. Bless you. So, if we look at this, you see three different examples. One where a parabola can go through the x-axis and then come back up. Doesn't matter whether it's concave down or concave up. I'm just demonstrating when it intercepts the x-axis twice. Right here at this point, wherever x coordinate that is, at that point, one real root. At this x value, one real root. When I say the word root, it has the same meaning as when I say the word 0, which has the same meaning when I say the word solution. So zeros, roots, and solutions are all synonymous. So if you look at this, and you look at the notes you just wrote down about whether the discriminant is positive, or negative, or 0, when we said it was positive, we said it had how many roots? When the discriminant is positive? Two real roots, and that would be the situation right here. So I can tell you that if we had the actual function on paper and we actually simplified the discriminant, it would definitely be positive because the fact that this guy, this parabola, intercepts the x-axis twice and therefore has two real distinct roots. In the middle here, this scenario here, we have a parabola that just touches the x-axis at one point, at one single point, where it changes direction, and this is when the discriminant is 0. Right? This is when we said the discriminant 0. We have one real root, and it's got a multiplicity of 2. That's this scenario right here. For those of you who are thinking about, remember intercept form, where you have a parentheses x minus p times x minus q. In this instance, p and q are the same thing. So for example, 3 parentheses x plus 4 times x plus 4. That's what it could possibly look like. Notice it repeats, where both x could equal x equals -4, x equals -4. That's that whole multiplicity of 2 thing. Only one real root. And then the last example here, if the parabola does not intercept the x-axis, 2 imaginary roots, which you can't see on this plane. Okay? This is where we have this imaginary plane. It's not the biggest piece, but let's say like this. They exist in another plane that you can't see on this screen here. Is just a real plane. Where if I stick my finger anywhere on this surface, the coordinates of where my finger just touched the surface are going to be real coordinates. No matter where I put my finger, they're all going to be real coordinates. There will be no imaginary coordinates. Which is why you don't see the zeros of this on this plane, because this is just a real plane. I would have to see it exist in another dimension, which would be the complex plane or imaginary plane. The imaginary plane would be perpendicular to this plane. If I could pull it off, you would see it hit the plane in 2 different points, the imaginary plane. So maybe the reason that it's called imaginary is because you have to imagine the plane, because you're not provided it. You're just provided this plane, the screen, or your paper if you're working on your paper. So doesn't touch the x-axis on this real xy plane. 2 imaginary roots. So these are the only 3 possible scenarios you can have for quadratics. 2 real roots that are distinct, 1 real root that has a multiplicity of 2, or 2 imaginary roots when it doesn't touch at all the x-axis on the real plane. So, page 124, number 8. It says, find the discriminant of the quadratic equation and describe the number and type of solutions of the equation. So number 8, you're given this, 1/2 x squared plus x minus 1 equals 0. Okay? Just looking at the discriminant, which is just the radicand part of the quadratic formula, which is just the b squared minus 4ac. Let's go ahead and do that. So b squared. B is 1. 1 squared minus 4 times A is 1/2. C is -1. Simplify, you get 3. Again, be careful. Make sure that you do in fact get 3, so you're not making a simple mistake. And so, the discriminant is 3. So the discriminant is positive. So, 2 real roots. So the homework that's due tomorrow is on the board. It's over here too. It's on the active board. Numbers 7 through 12. So 7 through 12, you're just finding the discriminant and then describe the number and type of solutions of the equation. So the answer to number 7, you say 2 real roots, and you've answered the problem. So let's go ahead and just do an exit ticket. Make sure you have the homework down. But go ahead and try number 7. As long as you're careful, you should be able to get what the value of the discriminant is, and then from based on its value, tell me whether it's 2 real roots, 2 distinct real roots, 1 distinct real root, or 2 imaginary roots.
Do you have the 1, 2, 4?
No, this is in your textbook.
Yes, I know, I didn't.
So if you don't have it, it's right here on the top.
Oh.
4x squared plus 8x plus 4 equals 0.
This is what I'm saying.